In the frozen heart of the Arctic, where temperatures plunged to -50 and blizzards could erase entire landscapes overnight, the Cold War produced some of the most extreme engineering ever attempted. Soldiers, scientists and engineers built secret outposts that had to survive months of whiteout conditions without resupply or sunlight. Most of these shelters failed, metal warped, concrete cracked, and air ducts froze solid. But one design stood out. It didn't just survive, it thrived. While other bases collapsed or were buried in snow, this shelter stood untouched for decades. Its secret wasn't brute force or exotic materials. It was intelligent design that worked with nature, not against it. Today, we'll uncover how this Cold War shelter defied the Arctic blizzards that destroyed everything else, and how the same principles can help modern survivalists, homesteaders, and off-grid builders create structures that can withstand extreme cold without power, fuel, or constant maintenance. Cold War engineers learned the hard way that the Arctic doesn't forgive mistakes. During the height of the Cold War, both the United States and the Soviet Union sought strategic dominance in the polar regions. The Arctic was more than frozen wilderness. It was a direct flight path for bombers and missiles. That made it a frontier for radar stations, communication hubs, and early warning systems. But the climate was relentless. By the late 1950s, the United States had launched the Distant Early Warning Line, or DEW line, an array of radar sites stretching from Alaska to Greenland. Soviet engineers countered with similar outposts across Siberia. The biggest challenge wasn't detection, it was survival. Metal towers buckled from wind stress, diesel generators froze, and snowdrifts buried ventilation systems. Many early designs assumed that shelters could simply resist the environment with thicker steel and heavier insulation. But Arctic wind has a way of finding every weakness. That's when a small team of Soviet field engineers working in the Taimyr Peninsula devised a radical idea that flipped conventional logic upside down. Don't fight the snow, use it. The secret to surviving blizzards was to build beneath and within the snow. Traditional shelters tried to stay above the surface, but in the Arctic, that's the most dangerous place to be. Wind-driven snow creates shifting dunes that can bury vehicles or expose foundations overnight. Instead of constantly digging out, the Taimyr engineers designed their shelter to use the snow itself as armour. They constructed the core shelter from timber frames and corrugated steel panels, but buried it halfway into a slope and allowed drifting snow to pile naturally over the roof. Rather than collapsing, the shelter became more stable as the snow compacted. Snow acts as a natural insulator. When it hardens under pressure, it maintains an internal temperature close to freezing, even when the outside air drops to -50 degrees Celsius. To prevent suffocation and freezing, they included a clever passive ventilation system, 2 vent shafts of different heights with wind caps. The wind's pressure forced fresh air in through the lower pipe and expelled warm air through the higher one. The result was a self-regulating airflow system that never needed electricity. Even during full blizzards, the vents stayed open thanks to heat radiating up from inside the shelter. By letting the snow and wind do the work, the engineers created a microclimate that was stable, insulated, and virtually invisible to aerial reconnaissance. This shelter stood buried for over 30 years before it was rediscovered, still structurally sound, with supplies inside preserved as if time had frozen along with the tundra. What made this design so effective wasn't high technology. It was the balance between structure and environment. The shelter didn't attempt to dominate the Arctic. It became part of it. The principles it used are surprisingly simple and deeply practical, even for today's survivalists. In extreme cold, heat loss happens through three things: conduction, convection, and radiation. Metal buildings lose heat through conduction. Airtight buildings trap condensation, which freezes into frost. But by using a snow cover as a natural thermal blanket and building walls that could breathe, the Tamir shelter maintained livable temperatures with only a small internal heat source, often just a kerosene lamp or body warmth. The same principle was applied in some US radar outposts in Greenland and Alaska after engineers studied how indigenous Arctic peoples built sod houses and igloos. The key was layering. Each material had a job. Ice and packed snow insulated. Wood provided flexibility. Airflow prevented condensation. It's a lesson still used today in passive house design. Don't just block the elements, channel them to your advantage. You can apply these Cold War techniques to modern survival shelter building. If you ever need to create a cold weather survival shelter or even an off-grid storage site, you can borrow directly from this Cold War design. First, use the terrain to your benefit. Building into a slope or hollow cuts wind exposure dramatically and gives natural insulation from the earth. Next, embrace snow cover instead of fighting it. A shelter covered in compacted snow can maintain a steady internal temperature even during long freezes. However, ventilation is vital. 2 vent pipes, one higher and one lower, will ensure airflow without losing heat. Warm air rises and escapes through the upper pipe, drawing in cooler, oxygen-rich air through the lower one. For insulation, mix natural layers. Wood, soil, sand, or even sawdust can buffer temperature changes and moisture better than plastic or bare metal. Modern preppers often add a vapor barrier on the warm side of the wall to prevent frost buildup, a concept that mirrors what those Arctic engineers accomplished with natural materials alone. This system works not just for survival bunkers, but also for off-grid food cellars, winter animal shelters, and emergency outposts. You're not just preserving warmth, you're creating a self-sustaining microclimate that keeps temperature, humidity, and airflow balanced with minimal effort. When researchers revisited those Arctic shelters decades later, many were shocked at their condition. Wooden beams remained intact. Air ducts were still functional. In some cases, even canned food was unspoiled. The snow that once threatened to destroy them had become their shield. That's the brilliance of Cold War engineering at its best. It was both practical and poetic. In a time obsessed with nuclear annihilation, these engineers created something that quietly proved the opposite. That survival doesn't come from domination, but adaptation. The same mindset that saved soldiers from Arctic storms now guides modern passive construction and sustainable living. It's a timeless principle. Work with the environment, not against it, and you'll build something that truly lasts. The Cold War shelter that defied blizzards isn't just a relic of military history, it's a testament to human ingenuity under pressure. It shows how balance, simplicity, and respect for natural forces can create structures that outlast generations. Whether you're designing an off-grid cabin, studying Cold War fieldcraft, or preparing for extreme climates, these lessons still apply. If you found this deep dive valuable, Make sure to subscribe to In the Beginning for more in-depth explorations into forgotten technologies, survival design, and Cold War ingenuity. Share this with someone who appreciates the art of building things that endure. Because sometimes the best survival secrets were buried in the snow long before we were born.